In our last video, we talked about indeterminate forms, things like 0 divided by 0, or infinity divided by infinity, or 1 to the infinity power, or 0 times infinity. So all these types of indeterminate forms. And remember to think about 0 as not the number 0, but actually a number infinitely close to 0. And infinity, well, we know is not a number, it's a concept, but when you see the infinity symbol, I want you to think in terms of a number that's just very, very large and approaching infinity, but not actually equal to infinity. So when you're looking at a problem like this, always attempt direct substitution first, which is a matter of taking your value that you're approaching, 0, plugging it into your function, and see if you can just find the output, the y value. So in this case, I would get 0 plus 4 minus 2 all over 0, which I can already tell is an issue. Square root of 4 minus 2 is just the numbers 2 minus 2. And so I'm getting, yeah, an indeterminate form, which is 0 over 0. So whenever something like that happens, I have to work a little bit harder to see if I can find the limit at that value as, well, x as approaches 0. So the value 0. So when it comes to a problem that includes a square root, this is a technique that applies for problems that have square roots in them. So we do a thing called multiplying by a conjugate. Now you already know what a conjugate is. For example, working with this kind of factoring. You would factor this as x minus 5 and then x plus 5. These two factors are actually conjugates of each other because the terms themselves, x and 5, remain the same in both, but here they're subtracted and here they're added. So it's the switching from subtraction to addition that makes these a conjugate pair. I'm going to apply that idea up here. Now remember in mathematics, we can either multiply by 1 or we can add 0. So in this case, I'm going to multiply by 1. And the one that I choose is very specific. It's going to be the conjugate pair to the numerator. So rather than taking x plus 4 minus 2, it'll be x plus 4 plus 2. And multiply it out this way. Now, if you've worked with conjugates and square roots, you probably know where this is going, but if you haven't, then let's take it a little slowly. This becomes the limit as x approaches 0. Notice I haven't actually taken the limit yet, so continue to write limit as x approaches 0 of this. Now I'm going to multiply this out really carefully using like a double rainbow or FOIL technique. So this times that just becomes x plus 4 squared. This times that 2 becomes plus 2, x plus 4. All right, move to this term. Negative 2 times that gives me a minus 2 times x plus 4. And then negative 2 times the positive 2 is just minus 4. All over. Now I'm not going to bother to multiply this out too much. I'll just leave it as x times square root of x plus 4 plus 2. I don't know that multiplying the x through would actually help me in this case. In fact, something might cancel, and it's going to be nicer to have it already factored in the bottom than to have to pull the x back out later. All right, you can already see that this term cancels with this term. That's the whole strength of a conjugate, you guys, is that when I switch the sign from negative to positive or vice versa, those middle terms cancel out. The other strength, which you might have noticed, is that when you square a square root, it basically just gets rid of the square root. And then I have this negative 4 at the end. All right. If I continue simplifying, I start to see that the 4's will cancel out with each other, and I have x over x times stuff. And like I alluded to earlier, the x and x match, so they are going to cancel. I am still writing the limit as x goes to 0 because technically I haven't taken the limit yet. but now when I plug 0 in, when I directly substitute, there's not going to be any kind of issue that pops up or arises, and so I can find the limit at this point. When I plug it in, I get square root of 0 plus 4 plus 2, and square root of 4 is just 2, so my answer is 1 over 4. So this is a technique that's called multiplying by a conjugate. I'm going to do one more problem if you want to see one more. If not, go ahead and stop the video, jump into some practice. Okay, so for our next problem, always remember to start by directly substituting in the value that you're interested in first. So that value of interest here is 0. So I'm going to attempt to directly substitute that in and see if I get an indeterminate form or not. Okay, so if I plug in 0 here, I get something like 3 minus the square root of 0 plus 9, which is just 9, all over 0. And I can see that 3 minus, well, square root of 9 is 3. So 3 minus 3 is 0 over 0. And this is an indeterminate form, which clues me in that I need to do a little extra algebra manipulation. Okay. The conjugate to this form, remember that the numbers, the terms themselves stay the same. So 3 and square root of 9, x squared plus 9, those stay the same, only the sign switches. So I'm going to multiply by this really specific fancy form of 1. In math, we can either multiply by 1 or add 0. And the form of 1 I choose is the conjugate because it's going to get rid of the square root and it's going to cancel out those nice little middle terms. Again, still writing the limit as x approaches 0 because I haven't taken the limit yet. When I multiply through, I get something like 9 plus 3 square root minus 3 square root, and then minus that squared. Notice here that the negative times that positive results in a negative out in front, so be really mindful with your parentheses and your subtraction as you go. On the bottom, I just have x times 3 plus square root of stuff. Okay, now go ahead and start taking steps to simplify. These guys cancel, and I'm left with 9 minus, I'm going to drop the square root now because it's been squared, so those cancel out. Notice here how very special that negative sign is. Okay, when I distribute that negative through, I get 9 minus x squared, but actually plus 9. Oh, sorry, it magically became negative. I was talking about negatives too much. Okay, so then that's a minus 9. All over x times stuff. All right, the 9 minus 9 cancel. And then one of these x's will cancel with one of those x's down here. So I'm essentially losing that square and I'm losing that x. So both of those are going to cancel, but I have one left over. Okay, so still haven't taken the limit. So now that it's fully simplified, I can directly substitute in that value 0 and see what I get. It's going to be negative of the 0 all over 3 plus square root of 0 plus 9. And I get 0 over, this becomes really 3 plus 3. Square root of 9 is 3, so 3 plus 3 is just 6. And it's okay to divide 0 by a number. Not 0 by 0, but 0 by any other number is just 0. And so I found that the limit of this function as x approaches 0 is just 0.